Hi, I'm Audra. We're now getting into the business of analyzing our data in this, our 5th podcast. In each of the test analysis podcasts, we're going to focus on a single test. As with our other podcasts, there are 2 assumptions that we have to make before we move forward. First, you're already familiar with research methods. The series isn't about teaching you how to go about research methods or even how to approach research. You should know about this before you start watching these. Second, you have a data set that you're trying to work with. The series is designed so that you watch some podcast material and then try it out yourself, or pause and go along. So let's move into the 5th installment in our series, running ANOVA and ANCOVA. In this podcast, after a brief introduction to ANOVA and ANCOVA, we're going to get straight into the demonstration of how to run and interpret the tests. So you'll need to make sure that your data file is set up correctly, that your factor analyses are run, and that you've completed your data analysis plan, identifying which tests you need to use to analyze each of your research questions and/or hypotheses. If you don't have all these things accomplished, make sure you go back to one of the starter podcasts 1 through 3 to guide you through. So here's what we're going to be covering. In Podcast 3, we established that ANOVA is used to determine whether there are significant differences between the means of 3 or more independent or unrelated groups. Now, what ANOVA does is tell you that there is some difference somewhere. In order to know where the differences are, you have to run a post-hoc analysis test. The only difference between the ANOVA and the ANCOVA is that there are covariates or control variables that you consider. For example, you may be interested in how nationality affects people's attitudes. However, there might be previous literature to suggest that gender and age affect their attitudes. With ANCOVA, you can ask the same question, focus on nationality, but you just do that by taking into consideration these other variables that we know typically do affect people's attitudes. So, how do we run ANOVAs? Well, we have to have our data set open, and again, because you're not doing anything with your data file, you're just running the statistics, it's easier just to keep the spreadsheet minimized and work directly off your output. So, our output is opened, and let's save this as our ANOVA file. So, remember that from our data plan, that the plan for hypothesis 1 and research question 2 identified these as being best tested or answered by the ANOVA. So what we're trying to figure out is if nationality and age influence trustworthiness and how much respondents trust the airlines after the introduction of a crisis. So, in order to do this, we go up to Analysis, then we come down to General Linear Model, and we come over to Univariate and click that. Now, let's expand our box so that it's a lot easier to find. Now, don't worry, there is a lot more here on the screen to take a look at than a t-test, but we really won't need most of it. So let's start by finding our dependent variable, post-test trustworthiness. And right here it is. So you highlight it, and you move it over to the dependent variable area. So now, what SPSS means by fixed factors are your independent variables. So let's get our 2 independent variables and put them into our fixed factors box. So our first independent variable is that of age, and it's our categorical one. So we move that over. And then we're also interested in nationality. So we move that over. Now, we go right to the options from here. We ignore the rest of this, and we ignore these first three boxes. Remember, in SPSS, checking less is better. Go to the third Post-Hoc and select it. Now, if you only have a 2-level variable, for example, gender, then you don't need to do a Post-Hoc analysis in ANOVA. If the test is significant, you know that there's a difference, and the difference is between men and women. However, in 3 or more level independent variables, remember, all the ANOVA F test tells you is that there's a difference somewhere. The Post-Hoc tells you where it is. So let's select both of our variables and let's move them over. Then let's select Scheffé. You can run any Post-Hoc that you want. I like the Scheffé test because it's conservative, that if it finds differences, you know they're usually pretty meaningful differences. So we check that, and we check continue. Now you want to ignore the save box, but do go into options. In options, select the following: descriptive statistics and the effects of estimate size. Don't worry about anything else. Click continue. Now we're all set to run our test, so click OK. Now, what you see in your output are a series of boxes. This first box just gives you the basic descriptions, how many there were in each of the categories. This is useful for your method section when you describe your sample. Now, as we go down, we'll come back to this second box, the descriptive statistics, because we probably won't need to think about all of these means. We'll really only be looking for the ones that are significant. So then let's scroll to our third box, the test of between subjects effects. This is the important one. So how do you know what you have? Let's work our way across the box from left to right. So in this left box is our list of variables, and then a few key pieces of information. In ANOVA, if you have a single variable, you would just see the corrected model, the intercept, and your variable name, the short version of it. Here, because we have 2 variables that we're considering, we have each of the variables listed individually, the age and the country, but then we also have this one, an interaction. It's asking, does age and country together influence our dependent variable? Now, you can ignore this second and this fourth column. This is SPSS just showing its work again. Now, the degrees of freedom, as well as the F and the partial eta, are important, but we'll come back to them. For now, let's just focus on our significance column. So you can ignore the corrected model row and the intercept. Again, this is SPSS just showing its work. Now, if you have multiple variables that you're looking at, you start at the bottom of the list, because what matters first and foremost is if your interaction is significant. If it is, then you ignore everything else for now. You ignore the main effects, which are the effects of the individual variables, and you ignore the post-hocs. You only report and discuss the interaction effect. So, is the interaction effect between age and nation significant? Yes, of course it is. Its p-value is 0.01. So, out of all of our data for right now, this is the important line. We know that age and nationality affect people's evaluation of the trustworthiness of an airline after a crisis has emerged. Now, let's come back to our partial eta squared. Think of a pie chart. The blank pie represents our dependent variable, an organization's trustworthiness. When we're analyzing our data, we want to try to account for as much of that pie as possible. Each test we run will account for a piece of that pie. The partial eta squared tells us how much of the pie we can account for by simply knowing a respondent's age and their nationality together. In this case, our 0.03 number translates into 3%. So our first hypothesis predicted that age and nationality would influence respondents' perceptions of airlines' trustworthiness after the introduction of a crisis. Based on these results, is our hypothesis confirmed? Of course it is. Now, for a more meaningful discussion of it, we would go back to our descriptives in our second table. And in our output, we try and highlight a few key points of discussion. The way that I would describe the results would be to produce a basic mean table. Now, this is a good point to note that it is never appropriate just to copy and paste SPSS printouts into your own Word table for a paper. They don't produce well. They don't conform to any of the key style guides for writing, for example, MLA, APA, or Harvard, so you need to produce your own table. Now, use the same basic rows and columns, so you would have age, you'd have nation, you'd have the mean, the standard deviation, and the number. Now, anyhow, the way that I would describe these results is to go back to these means, and for each of the categories, see if you can identify some of the basic trends for the numbers. So, for example, looking at the lowest, now in this case there's only one person who's 18 to 22 from Nigeria, I'd probably discount that for too few of respondents. But so I'd look at the lowest and the highest and do that across each of the age categories and see if there are some overall trends that you notice. Take note of them, write those in your notes on the results section, and then you can discuss them as you go down. Now, if you really want to drill down into the effects of your independent variables on the dependent variables, you can run separate ANCOVAs for each of the research questions that you'd created. So remember, we had a research question that specifically asked whether nationality would affect consumer evaluations of an airline's trustworthiness after the introduction of a crisis. Our research question 2. Now, because we already know that age also influences us, we can't just ignore this. And perhaps in the literature we found that there is also likely to be gender differences as well. So if we wanted to answer that question about the impact of national identity separately, we would have more error if we didn't take into account variables we knew or at least thought would have an effect. Statistics is all about controlling error. So that's why, if we were going to answer research question 2, we should run an ANCOVA instead of an ANOVA, because it takes into account and tells you how much your independent variable influences your dependent variable over and above any of these other factors. So let's go back and run our ANCOVA for nationality. So we start exactly the same. We go from analyze to the general linear model over to univariate. Now, this time we're only interested in nationality as our fixed factor, so we highlight age and we take it out. However, we want to control for age, so we want to put it back in the model by clicking it over under the covariate box. And we also want to do that for gender. Now you'll notice that the option for our Post-Hoc test went away. We'll be using the Post-Hoc test from our previous one, but the program doesn't allow Post-Hocs to run while taking into account the covariates. However, because SPSS saves all our other options, we don't need to go back through any of the rest of our menus. We just click OK to run the test. Okay, so as we take a look at the test, we notice that the printout looks basically the same. We give it a quick save. We have the same first 3 boxes. They're just smaller because we only have nationality considered for the means in the second box and the descriptives for each of the nations. Now, when we come to our third box to see if our results are significant, try this one kind of on your own. First, does nationality influence the perception of trustworthiness? If you said yes, you're absolutely correct. So, this is, again, if you need a quick refresher, that's what tells us that it is significant. So our p is less than 0.00. How about the pi? How much of the pi are we accounting for? If you said 0.04, you're absolutely correct. Again, we're looking at that figure, 0.04 or 4%. Now, what about our covariates? Did age and gender influence our test? So age, we already knew that one was the case, the 0.001. However, gender was not significant. Now, we have a big sample here, over 2,100 respondents. So we don't really need to worry about rerunning the test to see if one of our covariates, because one of our covariates wasn't significant, because that's not going to influence our variable of interest, nor the eta in any meaningful way. However, if you have a small sample, let's say 100 or less, you might consider taking out that gender one because it wasn't significant, because it might affect whether you end up with a significant result or not. When you have the smaller numbers, you need to be more careful about how many different variables you include. That's part of what the degrees of freedom, as you remember from your research methods course, will tell you. So how do you tell the narrative of this result? That is, what's the answer to research question 2? Does nationality influence trustworthiness after a crisis? Well, first would report whether our covariates were significant, and typically you don't need to report the F-test for this, just whether they were or they weren't. But then we'd say that basically, yes, nationality has a significant influence on consumer perceptions of airlines' trustworthiness after a crisis. Now, here we could look at our descriptives to offer a general summary. But to be honest, this doesn't really tell us that much, other than being able to rank them. So here's where we go back up to our post-hoc tests from before. So let's move up to those. Now, what this means, we're at the nation one. So what the Chaffee test does is compares each of the levels of our variable to all the others in order to determine whether the mean is significantly different. So we'll be able to tell if respondents from Bulgaria were different from respondents from the US or China, or if those are different from India. So all the test is doing is asking, is the difference between the first mean and the second mean significant? Now, how do we read this monstrosity of a table? Keep in mind the purpose. So, in this first column is the first column of comparison. We start with Bulgaria because that's the first one that was listed in our variables level list. So if you look down the first column, each of our 9 nations that were measured is indicated there. Now let's look at the top row. The second column on the left is the level of the independent variable that's being subtracted from the first one. So the next column over tells us directly that Bulgaria is being compared with China. The third column over is the mean for Bulgaria minus the mean for China. That comes to a negative 0.66. This means that the mean for China was bigger than the mean for Bulgaria. So let's go back to our simple means table and do the calculation ourselves. So, and we bring up a calculator because, we wouldn't want to do that completely on our own. So the mean for Bulgaria was a 4.0925. Then we subtract the mean for China, which is 4.7505, and we come up with a negative 6.66. I take you through this hopefully to show you that it's intuitive once you know how SPSS is reporting it. So let's go back up to our Post-Hoc table. Okay, so we have our mean difference. Now, ignore the standard error. This is SPSS just showing its work again. You can also ignore these last two columns because it's the same thing, the lower bound and the upper bound. So the last thing we look at and ask is that negative 0.66 for the difference between Bulgaria and China significant? Of course it is. So you do this for all of the levels, and keep in mind that about halfway through it becomes redundant. So once you do a comparison, you ignore it for the redundant one. So let's say in this first row, we've already compared Bulgaria and China. When you move down here and you're comparing China with the other nations, you skip Bulgaria because it's the same thing, just the inverse on the sign. Because it's China being subtracted from Bulgaria, you don't need to worry about it. So you've already looked at it. So when you're reporting your data for ANOVAs, it's typical to report the post-hoc results in a table and then summarize the highlights in the text of your result. You'd look at the key trends for what was significantly different based on the post-hoc tests. So once you've gone through the individual results, scroll to the table in SPSS listed homogeneous subsets. This will be right after the post-hoc table. Now, this gives us a clue as to how we should be interpreting all of our post-hoc results. And it tells you where the meaningful separations were in your data. So if we look at these, we can see 4 meaningful separations in the groupings. So the order of the means goes in the first group where trustworthiness was at the lowest to the group where trustworthiness evaluations were the highest. So if you want to think about it, Bulgaria, India, Oman, Hong Kong, the US, and Nigeria, their respondents rated trustworthiness the worst after a crisis. Yet on the other end of the spectrum, that China, Greece, and Singapore all rated airlines' trustworthiness after a crisis as the most favorable in comparison. So if you were asking questions about in which countries would airlines be most at risk, you can offer that kind of an analysis to discuss it. So these are the points that you would come up with as you're going along. What occurs to you, you report and you describe each of these, and then what do you think that it means in terms of both theory and practice? So again, it's all about trying to use the numbers to tell a story. But then we come to how you actually report all of these. So when you're reporting ANOVAs, there are 3 key pieces of information that you need to report in your results section. First, you need to tell the reader what kind of an analysis was conducted. If you don't, again, your results won't make as much sense. So in your methods section, you'll have already provided a justification for the tests that you've run. So in the results section, you offer a quick summary to remind the reader of why you've run a particular test. For example, a one-way between subjects ANOVA was conducted to compare the effect of nationality on the evaluation of an airline's trustworthiness after a crisis. If you had an ANCOVA, the sentence might read something like, a one-way between subjects ANCOVA was conducted to compare the effect of nationality on the evaluation of an airline's trustworthiness after a crisis, controlling for age and gender of the respondents. Second, you would want to indicate whether or not there are any differences between the means. As you do this, you include the following information. So, for example, you would say that there was or not a significant difference, put in the names, put in the reportings of the particular statistics. So, for example, there was a significant difference for nationality on the evaluation of an airline's trustworthiness after a crisis, and the test statistics demonstrate that F, the degrees of freedom, the test, the p-value, and the eta squared. And we'll come to this in just a minute on how it actually looks all together. Third, then, if your test was significant, and only if, then you report the post-hoc results. If your test isn't significant, you don't need to report the post-hocs. Now, most typically, when we're running tests, we have a lot of them, so we've used the table. Or if you only have maybe one or two ANOVAs with just a few levels, you can write them out. So this would give you a sample script for writing them out in the text of your paper. So let's come back to our research plan for the ANOVA. This was our hypothesis, and this was our research question that we identified as using ANOVA or ANCOVA in order to test the effectiveness. So from here, reporting your findings in your results section and creating a table is just a matter of plugging the numbers in from your SPSS output into some basic stock sentences or table layouts. Now, again, remember, when we have interaction effects, all we report is the equation and offer some general discussion. We don't report any of the post-hocs or anything like that. So, if you take a look at the model sentence, but then if you substitute our numbers for the example of the interaction effect, our example with nationality and age, that sentence might look something more like this. There was a significant interaction effect for the influence of age and nationality on trustworthiness. F, with degrees of freedom of 40 and 2054, equals 1.56, and the P equals 0.01 with a partial eta squared of 0.03. Now, let me show you where we put those in from. So we go back up to our interaction effect test. Our between subjects test was right here. So our F at 40 in ANOVA, the first degrees of freedom is always representing the number of levels that were considered in the test. In this case, it was 40 different levels. Then your second number is always the error degrees of freedom, the total number in your sample minus any of your control variables and or your test variables. So 40 and 2054. The F test, then, the 1.56, comes from right here. We put that right there. The p-value, again rounded to just two numbers, 0.01, and the partial eta squared. In statistics, you become one with the Greek. So if you use the font symbols, you use that for the lowercase eta. So the eta equals a 0.03. Now, if we substitute the numbers for nationality alone, we scroll back down to our nationality alone data set or result, and so we go the F, the 8, and 2098. So we put those two numbers right there. Our F value is the 11.74. P is less than 0.00. Remember, if we're reporting our p-value and it's a 0.000 or below, we don't say it equals 0. There is no such thing. You put the less than and the 0.00, and then our eta as a 0.04. Then, I always like to put in, for these, see table X. You number your tables in the order that they're presented for post-hoc comparisons. So, that's the basic text of what you report. Now let's take a look at the table. Now, let's start at the top row to see what's been included. The independent variable, obviously nation. Our dependent variable, trustworthiness. Now remember, we're doing this for the individual test. So we put on our degrees of freedom again. This gives the reader an at-a-glance of the entire test. So it's worth repeating the degrees of freedom, the F-test, and the P-test. So the 11.74, 11.74, the P should really be the less than 0.00, and on this one we leave out the partial eta. Now, from here, on separate lines, we report each of our significant post-hoc tests. So that means we come back up to our big table. I've already filled this in for you. So, a few things to notice here. First is that as we look down the significance, we can see that Bulgaria only has major differences from China, Greece, and Singapore. So we report those, we report the mean difference, the I minus j, and we report the significance levels for each of those. So less than 0.00 for each of those. However, as we move down to China, we can see that the only country that it had a significant difference from was in fact Bulgaria. We've already reported the difference between China and Bulgaria, so it doesn't come up here in our test again. Instead, we go down to Greece. Again, we've already reported the China-Bulgaria difference, so the only other one that there was a significant difference for was for India. And so we report the India, the 0.69 and the 0.03 on the significant difference, on the p-value, and then we come through the rest of them. You go one at a time through these. So you'll notice that our massive SPSS table really gets boiled down to a much more manageable one. This makes it easier, it condenses everything, and it makes it more clear. This is another one of the reasons that I like to get my tables made as quickly as possible so that I don't need to look at the SPSS printouts. This gives me, at a quick glance, the information that I need as I need it. So, on each of those separate lines, we report each of those. Now, if I have several ANOVAs to report for a single independent variable, so let's say that I had 4 or 5 different dependent variables that I looked at for nation, I could report those all in a single table to make it a little bit easier, and the results for our independent variables of interest, report those in a much more condensed way. This makes it clearer. You get everything and all the data delivered in a much simpler, more succinct way. Now, in our data, you'll also notice probably that Singapore was the one country that was substantially different from others. If you wanted, you could have just gone through the Bulgaria and the Greece differences, and then you notice that it's just Singapore throughout. So you could have put Singapore over here under Post-Hoc I and reported the rest that way. This is an aesthetic choice. It's whatever you want to do in that case. There will a lot of times be one variable or one level of your independent variable that really stood out. If you can isolate those and report those, it makes your discussion and results section a lot more effective. So, As we think about how all of this comes together, a best practice for you is to do this as you go along with your tests. Like I've mentioned in previous podcasts, if you can do your tables and basic results summary as you go along, it makes it easier. You get the SPSS printouts out of your way and you have the results translated and summarized. It makes writing your results section then a matter of simply assembling everything. Again, it's worth mentioning that even though ANOVA and ANCOVA are kind of complex statistics, we're still unscathed by mathematics. It's just reasoning with numbers, knowing how to run them, and what to report. And so this concludes our 5th podcast on ANOVA and ANCOVA. Coming up in our next one, we take a look at correlations.